Welcome to springlib.
Hi everyone, so what we have here is a problem that involves a boy sliding down a spiral slide, which has a spiral path, such that the delta z is a negative 2 meters and his speed is 2 meters per second. We know the mass of the boy to be 40 kilograms, and what we're asked to solve for are the radial, theta, and z components of force that the slide exerts on him at this instant. The way we're going to be solving this problem is by using our knowledge of rotational, tangential, and linear motion, and we're also going to be using Newton's second laws and developing equations of motions to solve for these forces that are acting on this boy at this instant. So what we're going to go ahead and do first is draw a free body diagram. Here's our boy. Here is the normal force that is acting on the boy at an angle theta, which we do not know yet. And we also have the radial force that is acting on the boy as well. And we also have the weight force. We can actually go ahead and find this unknown angle theta by using the knowledge that we know of the velocities and displacements. So another piece of information that's given to us is the radius of the slide. We know the radius of the slide is 1.5 meters. So we know that for every 2 meters down that's traveled, the boy is traveling 2 pi r, so 2 pi 1.5 meters in the tangential direction. This yields us a theta that's equal to 11.98 degrees, and that's that angle here. So using this information, we can go ahead and write down Newton's second laws. So what we can do is we can say that the net force in the theta direction is simply just going to be equal to m times acceleration in theta, which is equal to nb sine 11.98 degrees. And then our net force in the z direction will be equal to m times az, which is equal to negative nb cosine theta, so 11.98 degrees, plus our weight force. So now what we can do is we can actually go ahead and solve for accelerations. And the way we can do that is by using our knowledge of tangential, linear, and motion in theta. So we know our r is 1.5 meters, and that's going to be constant. Therefore, r dot and r double dot are equal to 0. Next, what we can do is we can go ahead and solve for v theta, which is going to be equal to our speed times cosine 11.98, and this gives us 1.956 meters per second. We can also solve for our our vz, which is going to be equal to negative sine 11.98 degrees, and that gives us negative 0.4152 meters per second. Next, what we can do is we can say that v theta is equal to r theta dot. Therefore, theta dot is equal to v theta all over r, which gives us a theta dot equal to 1.3043 radians per second. We can use this piece of information with our theta dot to solve for our net force in the radial direction. We can say that the net force in r is equal to m times ar, which is equal to negative fr, which is equal to 40 times the quantity 0 minus 1.5 times theta dot squared. This gives us an FR that's equal to 102 newtons. So that's one part of our answer. Next, what we can do is we know that tangent of 11.98, which is our triangle that we got from the displacement, is going to be equal to the motion in z over the motion in theta. So this is essentially az over a theta. Therefore, we know that a theta is equal to 4.7123 az. Using this piece of information, we can solve for and say that az is equal to 0.423 meters per second squared, and A theta is equal to 1.99 meters per second squared. Recall that our Newton's second law in the theta and z direction yielded us that NB sine of 11.98 degrees is equal to 40 times A theta, and that negative NB sine 11.98 degrees plus 40 times 9.81 is equal to 40 times AZ. So using these two pieces of information, we can go ahead and solve for NB. And what we see is that NB is equal to 383.85 newtons. And using this piece of information, we can go ahead and solve for Fz and F theta forces. And we'll see that Fz is equal to n times cosine of 11.98. This gives us an Fz equal to 375 newtons. So that's another part of our answer. And we can also solve for F theta, because F theta is just going to be equal to n times sine, or NB times sine of 11.98. And this gives us an F theta equal to 79.7 newtons. And that's the last part of our answer.